We're going to be starting 2.8 today, but to start off we need to review 2.7, our absolute value equations. So without graphing, identify the vertex, axis of symmetry, and transformation from the parent graph. So we have y equals absolute value of x minus 2 minus 6. Okay, so go ahead and identify the vertex, axis, symmetry, and transformations. Come back and we will discuss them. So again, the vertex is normally at 0, 0, but since we have stuff added or subtracted, our vertex will now be moved to 2, negative 6. So our vertex is at 2, negative 6. Again, don't forget to put it in parentheses with the comma in between. Our axis of symmetry is the same as the x value of your vertex. So we have x equals 2. And the transformations we have done, we have moved our vertex to the right 2 and down 6. We have no vertical stretch or compression or reflection. So 2.8, two variable inequalities. So we're going to be graphing and identifying how to graph these. So maybe we're going to be shading if you've never heard of inequalities before with graphing. So a linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line. So we could have y greater than 2x plus 3. Again, that is a line. This example is a line, but instead of having a solid line, we could have a dashed line, and the greater than or less than symbol means we have to shade. Now to figure out how to shade, we can do this by using a test point. So if I have a line here, and I pick any point not on that line, I can use that to help determine whether to shade that region or not, and we'll go over that more in detail later. So when we are graphing our linear equations in two variables, notice how we have less than, or we have less than or equal to. Same thing for greater than or greater than or equal to. And that means we can have solid or dashed lines. The ones that are less than or greater than without the equal to signs, those would be a dashed line. So your line will look like this. Not all filled in. But if we have equal to, that will be a solid line. So like we were graphing before. Now there are a couple steps when graphing inequalities. You first, if it's not already solved for you, solve the equation for y. Then we have to graph the line for the inequality. Use the dash for less than or greater than. And we have to use solid line for less than or equal to or greater than or equal to. Then we test a point not on the boundary line to determine whether it is a solution. If it is not a solution, we shade the other plane. If it is true, we shade the region that includes that point. So when we have y equals or x or y greater than or less than, so we would have this, y greater than 3. We would shade above that line because again it would be a straight horizontal line. So if it is greater than, we shade above, less than, we shade below. If we had x greater than 3, that would be a straight vertical line. And then we got to shade to the right or to the left. If it is greater than, we shade to the right. If it is less than, we shade to the left. So let's try a couple. Y less than or equal to negative 3. Again, since it is y, that means our line will be a horizontal line only going through the y-axis at negative 3. So if we plot the point negative 3, our line will go through that point, being horizontal. Then we got to look to see if it's dashed or solid. Since it is equal to, less than, or equal to, it will be a solid line. So I have a solid line here. And then we got to determine, since it's inequality, whether we shade above or below. Since it is less than, if you look at your point below, negative 4 is less than negative 3, so you would shade this region here. Next, let's talk about x. Okay, so it is x, so we plot our point on the x-axis, meaning our line will go through that point on the x-axis. Again, it is a line, not just a point there. Since it is not equal to, it will be a dashed line, so make sure you leave some space. We can't just draw a straight line. And have your arrows. And then we have to determine shading to the left or to the right. Since it is less, x is easy, less, left, we go to the left. We can also check, put the point 1, is 1 less than 2? Yes, so we include the region with that point. Now it's where we add our slopes in. The first one we have y greater than negative 2x. Again, this is in slope-intercept form, so we have to add or subtract a number at the end. Since there's not a number there, we can just put a 0. So we start our graph at 0. We graph our line. Hopefully you know how to graph a line by now. Since our slope is negative 2 over 1, we go down 2 over 1, down 2 over 1, down 2 over 1, or up 2 over 1, up 2 over 1, up 2 over 1. Next, we gotta look to see if it's solid or dashed. Since it is not equal to, it will be a dashed line. So I normally just draw dashes in between my points. Extend it past your graph a little bit. Have your arrows. And then last step is to shade. Now, this one gets a little tricky because we don't have a straight vertical or horizontal line, so we have to pick a test point. I normally like to pick 0, 0, but since our line goes through that point, we cannot pick it, so I'm going to pick a point that's not on our line. So I'm going to pick the point 1, 0. So this is our test point 1, 0. That means 1 is our x value, 0 is our y value, so you got to plug it into our equation. So we plug in 0 for y, so we have 0 greater than, and then we take negative 2, plug in 1 for x, that's negative 2. Now we got to ask ourselves, is 0 greater than negative 2? It is. So since it is true, we shade the region that includes that point. So we shade this region here. Okay, for our next example, remember our first step is always make sure our equation is solved out for y. So go ahead and solve that out for y. We should get y. I'm going to leave a blank for my inequality because I got to talk about that. 5 halves x plus 2. Now, the reason I left that inequality blank for the current moment is because notice how we have a negative 2 out front of our y. Don't forget, when we solve these out, you must switch your sign of your inequality. So now this becomes greater than or equal to. So graph your line. We start at 2 on the y-axis. And our slope is 5 over 2. If I would go at 5, I'd be off my graph, so I'm going to go down 5. So I'm going to go down 5, 1, 2, 3, 4, 5 over 2. Okay, those are the only 2 points that will fit on my graph, so that's good enough. Next, it will be a solid because we have equal to. Make sure it goes to that point, a little off. Okay, next we got to figure out which way to shade. Since our graph does not go through the point 0, 0, I'm going to plug that point in. That's the easiest one to plug in because this will become 0, this will become 0, and we're left with, is 0 less than or equal to negative 4? Is that true? Is 0 less than negative 4? It is not. Since it is not true, we shade the region opposite that test point, so we shade up above our line here. Alright, so next we have to do our lovely word problems. I know you guys love these. Alright, so a film class is recording a DVD of student-made short films. Each student group is allotted up to 300 megabytes of video space. The films are encoded on the DVD at 2 different rates, a standard rate of 0.4 megabytes per second, for normal scenes, and a high quality rate of 1.2 megabytes per second for complex scenes. Write an inequality describing the possible amounts of time available for standard and high quality video. Now, since we have 2 different rates, standard and high quality, we're going to have 2 different variables. So we're going to have, I'm going to put our standard rate of 0.4 with x, and we're going to add to that our high quality rate, which is 1.2. And since that is a different kind, it's going to have a different variable. And we only allotted up to 300 megabytes, so that means these cannot be greater than 300. So it would be less than or equal to 300. And you are done. So we have a couple more examples. Y greater than 3x minus 1. I think you guys can handle it by now. You can graph this line, determine where to shade. And the same thing for the next one. Just notice how the signs are different. You have the same line except for the inequality symbol. Let's go ahead and graph those lines and come to class ready to talk about them tomorrow and to work on this homework.